Hi guys and welcome back to my channel. I'm Chelsea. So today we're going to be talking about osmosis. Osmosis is basically very similar to diffusion, and I will not be spoon feeding you in this video. Just a brief overview. So the introduction to osmosis is quite similar, or quite simple actually. It basically defines the movement of water molecules from one high concentration to one low concentration. High concentration basically means where there's an area of more water molecules, not water itself, or you could say that, but it's just less clear. And to an area of low concentration. Low concentration means the opposite of high, i.e. less water molecules. Now, is generally used with water molecules and not maybe other molecules, say oxygen molecules, because that's kind of the main differences between osmosis and a later subject called diffusion, which I already have a video on. What osmosis is. Now, it's not that osmosis, it's the other one, the scientific one. As I was saying, osmosis is, again, defined as the net movement. The net movement. Net movement means the overall movement, overall change, moving from one side to another or vice versa, right? The net movement is zero at the point where you reach even sides, right? Even sides. So this side has a lot, and this side also has a lot, or this side has few, and this side also has few, right? They are generally equal, generally. So it doesn't have to be 1 equals 1, or 300 equals 300, or 63 equals 63, right? Okay, it doesn't have to be that equal. It just has to be sort of precise. And also, osmosis is, again, specifically dedicated to water, and there are many other definitions for osmosis, such as this guy, but we're going to be purely focusing on the thing osmosis, the scientific thing. It can normally be passing through a semi-permeable phospholipid, let's just say membrane, and it can also be passing through empty space, though it is normally defined passing through a membrane. What osmosis, or how does it work? Osmosis is really similar in a way. Basically, you have some water molecules and they're traveling through a membrane. I just put a cell membrane here because I'm lazy. So the water molecules, like I've drawn here, they will generally have a net movement that way down to the other area, and it's not because of gravity. It generally can be the other way. It depends on what side has generally more water molecules. Since this side now has clearly more water molecules, you can count, then the net movement will normally go that way unless there's some other pressure. Now, there is a lot of mix-up between osmosis and diffusion, so we may as well cover it. The difference between osmosis and diffusion. Osmosis is quite similar to diffusion, and I've also pointed this out in my previous video of diffusion. So it's kind of hard to say when two things have let's say 68 different 68 similarities, and they each have only one difference, right? Both involve a substance traveling through space, normally with their gradient. That's called passive transport, and both involve may or may not having a membrane, having the substance go through. Only one is specifically dedicated to water, one of the differences, and one is dedicated to anything. Diffusion is like when you spray an air freshener and then people near you smell it right away, and then maybe people further from you smell it later. That's diffusion. But in osmosis, it's more like the image I've put here, and that's obviously not good for whatever this is. Okay? What is an equilibrium? Equilibrium basically means equal, obviously. Equilibrium means, let's say we have an equal number of water molecules and solute molecules and all that dirt and things inside the water. Both sides are equal. This is equilibrium. But what if we added some salt to only one side? That one side will usually rise if osmosis is happening because it has less water and more salt. That way it'll rise up. Same goes for the other side if it were to have more salt. Assuming there's a membrane in between that stops the water from spilling out, and that the salt cannot pass through the membrane itself, but the water can. Right, and diffusion is also dedicated to this equilibrium, and there's also another type of diffusion called facilitated diffusion. It's also a passive transport, meaning it doesn't take any energy, except that facilitated diffusion requires molecules traveling through a passageway, let's say, a passageway into a cell or some kind of membrane. that doesn't really require any energy, like ATP, adenosine triphosphate, nerd. So we can usually refer it to as a passive transport, and I will not be referring to that meme again. So yeah, this is the overall thing about osmosis, the overall covering. I hope you like this video. So yeah, thank you.